Have you ever wondered how electricity is safely controlled in power systems? It's like a water faucet, but instead of water, it's a flow of electrons. One crucial component that helps in this control is a vacuum circuit breaker, or VCB for short. VCBs are essential for protecting electrical equipment and ensuring a reliable power supply. Think of VCBs as super-fast switches that can interrupt the flow of electricity when there's a fault, like a short circuit. They are designed to handle high voltages and currents, making them ideal for applications in power plants, industrial facilities, and even some residential areas. What makes VCBs unique is their use of vacuum as the interrupting medium. This means that the electrical arc, which is generated when the circuit is interrupted, is extinguished within a vacuum chamber. This vacuum environment provides exceptional insulation and arc-quenching properties. In the next section, we'll delve deeper into the fascinating world of VCBs and explore how they work their magic. Imagine a glass jar with all the air sucked out. That's a vacuum. Now picture two metal contacts inside this jar. When these contacts are touching, electricity can flow through them. But what happens when we need to stop the flow? This is where the magic of VCBs comes in. When a fault is detected, the contacts are rapidly pulled apart inside the vacuum chamber. As the contacts separate, an electrical arc forms between them. This arc is like a mini lightning bolt, but instead of air, it ionizes metal vapor from the contacts. The beauty of a vacuum is that it has a very high dielectric strength, meaning it can withstand high voltages without allowing electricity to flow. This allows the arc to quickly extinguish within the vacuum chamber, interrupting the flow of current. The vacuum interrupter is the heart of a VCB. It consists of the vacuum chamber, the contacts, and a mechanism to move the contacts. The entire assembly is hermetically sealed to maintain the vacuum. Just like any piece of sophisticated equipment, VCBs require regular maintenance to ensure they operate reliably and safely. Don't worry, it's not as complicated as it sounds. One of the most important aspects of VCB maintenance is visual inspection. This involves checking the breaker for any signs of damage, such as cracks, loose connections, or corrosion. Regular cleaning of the breaker's exterior is also essential to prevent the buildup of dust and debris, which can affect its performance. Another crucial maintenance task is contact inspection. Over time, the contacts can wear down due to the arcing that occurs during operation. Inspectors use specialized tools to measure the contact wear and determine if they need to be replaced. It's important to remember that maintenance should only be performed by qualified personnel who have the necessary training and experience to work with high-voltage equipment. Safety should always be the top priority. Now that we understand how VCBs work and how to keep them in tip-top shape, let's discuss why they are such a popular choice in the world of electrical engineering. One of the biggest advantages of VCBs is their exceptional reliability. Because the vacuum interrupter is a sealed unit, it is not susceptible to environmental factors like humidity, dust, or contamination, which can affect other types of circuit breakers. Another major advantage is their long lifespan. VCBs require minimal maintenance and can operate for tens of thousands of operations without needing to be replaced. This makes them a cost-effective solution over the long term. Furthermore, VCBs are environmentally friendly. Unlike some older circuit breaker technologies that use oil or gas as the interrupting medium, VCBs do not produce any harmful emissions or byproducts. In conclusion, vacuum circuit breakers play a vital role in ensuring the safety and reliability of our power systems. Their unique technology, low maintenance requirements, and long lifespan make them an excellent choice